Welcome to the basic tutorial of the Modular-X machine vision software developed by SANXO Systems. In this video, I'm going to show you the basics of using this software. Modular-X is a LabVIEW based software. It uses the powerful LabVIEW Vision library. It supports USB and Ethernet cameras by IDS Imaging, and Ximea CURRERA cameras also includes the iMac driver from LabVIEW. Therefore, you can connect any type of cameras that is supported by iMac and acquire image from the cameras. So let's begin our first tour with the interface, and I'm going to show you how to develop an easy application for a production line. It's really easy to use it. You will see in a few clicks we can build up a quite complex application. This is the user interface with the menus, programming tools, and the inspection steps palette over here. The inspection steps palette is in an order according to machine vision application. For example, first of all, you have to acquire an image from a camera. Also, you have the opportunity to simulate this step, and then image enhancement to prepare your picture for processing, like gray filters, gray morphology, and binary tools over here. Also the locate features to locate different kinds of edges, build up a coordinate system, detect objects on your image, and so on. Measure features to measure things on your picture, like you can count pixels, you can measure intensity, Gauge measurement, and geometry measurements. You can identify parts by reading the barcode in it or data matrix. Also, you have opportunity to communicate with the production line through serial I/O, through digital I/O. This is supported by the DAC from LabVIEW. And also you have an opportunity to interact with users. And additional tools, different kind of tools for example, calibrate the image to get the measurement data in absolute values like millimeters, for example, and logical calculator to make logical relations between results, and so on. We got programming tools over here to make conditions and develop loops, and also the menus to create a new project, new session, rename, delete your session, save your project, load your project, and import a session from another project. Edit menu to edit the steps in the sequential tree, and operate menu to do things with your session, for example, to check the syntax and run your session over here. You can do it by pressing the Ctrl and R. View menu to zoom in, zoom out, and zoom fit options. Here you can manage the sessions. You can run 3 sessions at the same time. If you might want to add a session, then you just have to click over here and type the session name, for example session 2, then you create it, and now we got 2 sessions at the same time, and this can be run parallelly. So let's go back to editor mode, and also you got the help menu over here. This brings up a how to use the Modular-X anytime by pressing the function 1. I told you about sessions, but maybe you might want to ask, what is a session? A session contains steps those are used during the machine vision inspection. And as I told you before, in the session manager you can create sessions up to 3 sessions to run parallelly at the same time. It means that, for example, if you have 3 cameras on your production line, you can handle them and run parallelly 3 different kind of tasks. Also, there is an opportunity to handle all the cameras in one session, but in that case you can just handle them sequentially according to the tree system we are using in Modular-X. So it's time to build our first application, and I'm going to show you how to do this. We are going to use the iMac step to acquire image from a camera, I've got a Logitech camera here. So by the way, all your cameras, those are recognized by the Mac driver, are going to appear in this list. So I'm going to choose the Logitech camera, and let's give a name for the step like acquire image. And then let's test your camera by grabbing an image from it. Yes, and it works pretty well, as you can see. You have lots of options here, but now this time I'm not going to spend time with it to set up, so I'll just click on the exit button, and then your step is going to appear in the session tree. And then if you click on the run session button, then it is going to grab an image from your camera. So as you can see, I've got a GitHub pic on the picture, and I'm going to show you how to recognize this by the software. There's a specific step called geometric matching to do this task. The geometric matching step locates regions in a grayscale image that match a model or a template. Geometric matching is specialized to locate templates that are characterized by distinct geometrical shape information. And because geometric matching is a template-based step, users have to create their template and define the shape of the object if it is not detected correctly. You can find this step in the locate features in geometric matching. Let's give a name for the step like find pic, and set the region of interest. There we are looking for the object, and in this case it's full image. And then click on the new template button. It opens a window with the template editor over here, and now select the template region. This is the peak, and then let's go to the define curves tab and set the edge threshold value. Because we want to detect low contrast edges, this value must be set lower, so let's set to 25. And then as you can see, it detected the shape around the object. And let's go through the other tabs. As you can see, there are many options over here, but this time we are going to go through this, and then save the template as pic. I already created one before, so I want to replace it. Yes, and then you can close this window. And then, as you can see, it found the pic and the image, but we have to set up a few parameters before we go to the inspection. So here we have to set the edge threshold value, because in the template editor we use this value to detect the curves around the object, and in this time you have to set this parameter for the function. So let's set it to 25 as before, and as you can see, there is a score value, and it is 1000 because the stored template exactly matches the appearing pic on the image. Let's go to another parameters like rotated, because we are looking for rotated pics. Also set this value to 0 to 360 degrees, and then specify when the step passes the inspection. Here you have to define the minimum number of matches, and in this case we have to set this to 1. So after setting these values, we can accept, and as you can see, this step is going to appear in the session tree over here. Before we run the session, let me build a loop, a while loop, and there is an important step to do. We have to define the display result image. It means that which step is going to give the image for the display over here, and we have to select, in this case, the find pic step. So if we will select this acquire image step, then we will just see this picture, but if we choose this one, then the overlay is going to appear on the image. So, and now let's run our session. And as you can see, it is running and the values are changing, the result values, the score. And I can just turn it around and pull it back and turn it around again. I can put there another object, but it is just going to recognize the peak over there. So this is how you can detect an object on the image with the geometric match. And so this is all I wanted to show you in this video. I guess you got the basics of using this software. If you have questions, then you can contact us. You can find the details in the video description. And I hope it was useful for you. And keep updated, because we're going to post more videos related to using the software. Thanks for watching. Bye.